Have you ever thought about how, like, the search engine you use every day,
Yeah.
the one you totally rely on, could actually be way less effective in just a few months?
Yeah, I mean, things change so fast online.
Exactly. It's crazy how quickly things evolve, and even the best tools really need constant updating to keep up, you know. And that's actually what we're going to explore today, this whole challenge of keeping information retrieval systems working well, but not just today, but over time.
It's a huge problem.
And, you send over some really interesting stuff about this, all pointing to what's going on at the LongEval lab, which is part of CLEF 2025.
Oh, yeah, CLEF.
So we're going to dive into why this idea of keeping things working well over time, temporal persistence they call it, is so crucial for the information you and I are trying to find.
Yeah, that's the key. It's got to stay relevant.
Right. And we'll also look into what researchers are doing to make sure the information stays high quality over time.
Absolutely. It's easy to just assume, when you type something in, you're going to get the best, most up-to-date answers.
Right, like it's magic or something.
But the internet, and really all information in general, it's constantly in motion, New stuff pops up all the time.
Oh, yeah, all the time.
What people are interested in changes, and even what we consider a good result, well, that can shift too.
Yeah, that's a good point.
So it's a really complex problem, making sure those search results actually stay useful and not just for a moment.
Okay, so let's break down this whole evolving search setting thing. It's more than just like new websites appearing every day.
Oh, for sure.
What are some of the maybe less obvious ways this information landscape is shifting? The things that make it a real challenge for these systems to be effective over the long term.
Well, think of it like a massive library.
Okay, I can picture that.
Yeah, so every single day there are tons of new books being added.
Right.
And that's like the equivalent of the constant flood of information online.
So much new stuff, it's overwhelming.
Right. But on top of that, people's reading habits are also changing.
Makes sense.
Some topics, they become super popular, others kind of fade away. And that reflects the changes in what users are looking for, what they need, and what's considered relevant at that moment.
Yeah, and what's trendy now might be totally outdated in a few months.
And then there's another layer to it. Over time, some of the older books, well, they might not be as accurate anymore, or they're just not as helpful for current research.
Yeah, kind of like how medical advice changes over time.
It's like that, exactly. It's what we call temporal decay of information. So to keep this library useful, you can't just keep piling on new books, right?
Of course not.
You have to reorganize, update, maybe even archive some things.
A never-ending process.
Yeah, and the thing is, traditional ways of evaluating how good a search engine is, well, they often just take a snapshot in time.
A quick glance, basically.
Yeah, they don't really consider this continuous evolution that's happening.
So they miss the big picture.
Yeah, they miss how things are constantly in flux.
Okay, so that's where this LongEval lab comes in. It sounds like they're taking on this temporal persistence problem head on.
Precisely.
And they've looked at this before, right? It's not a brand new thing for them.
You got it. LongEval at CLEF 2025 is actually their third time running this lab.
Wow. 3 times.
Which really goes to show that the research community sees this as a big challenge.
Yeah, it's clearly an ongoing thing.
Absolutely. Their main goal is to figure out how well these systems are working, how effective they stay over time. This whole temporal persistence, or sometimes they call it temporal generalizability idea.
Right, making sure the information remains useful even as things change.
Exactly.
And they use this thing called longitudinal evaluation for that. What does that actually mean? I'm guessing it involves looking at performance over a longer period, not just a one-time check.
Yeah, you're right on the money there. Longitudinal evaluation means they're testing how well the system works, but as the information it's being tested on gets further and further away in time from what it was originally trained on.
Okay, so they're creating this gap, basically.
Exactly. And that time difference, they call it lags. So instead of just testing it on data from, the same time it learned, they might test it on data from, 6 months later or even a year later.
And the idea is to see if it can still provide good results even with that time gap.
Exactly. They want to see if those results are still useful.
It's kind of like, if you had a weather app trained on last year's weather patterns, could it accurately predict what's happening outside your window right now?
That's a great analogy. And the goal is to understand how much the system's performance degrades over time. And what's really interesting is that what they found in previous LongEval labs, it's not always the initial top performer that stays the most reliable as time goes on.
Oh, that's a bit of a surprise, isn't it?
Yeah.
You think the best one would just stay ahead of the pack?
You would, right. But it turns out there might be different things that make a system good at a specific point in time versus making it good over the long haul. Like, one system might be super good at picking up current trends in the data, when it was learning.
Yeah.
But then it might have a harder time adapting as those trends change.
So it's like a sprinter versus a marathon runner.
Perfect analogy. So LongEval 2025, they're focusing on a couple of specific areas, right? It's not just about general web searching anymore.
Yeah, they've expanded their scope.
They've added scientific publications into the mix.
Which makes sense. That's a whole other world of information.
Exactly. So now they can see if these changes, how they affect different types of information and different users, like researchers using scientific databases.
So let's start with the web search part, LongEval Web Retrieval. This one builds on their previous work and uses data from the French search engine, Quant.
Quant, yeah.
Now, the original data is in French, but they actually provide English translations so more people can participate.
Yeah, it opens it up.
This task is all about seeing how things work in real-world situations. They take these monthly snapshots of websites and user searches from Quant.
Monthly snapshots, yep.
And these snapshots, they represent those time lags we were talking about earlier.
Exactly. And the key is that all the testing data comes from after the period that the systems were trained on, so it's truly testing their ability to deal with brand new information.
So can they handle what they haven't seen before?
That's the big question. And for 2025, we're talking about a massive amount of data. 30 million documents and 15,000 search queries. This data covers the period from June 2022 to August 2023. The systems learn from June 2022 to February 2023, and then they're tested on the data from March 2023 to August 2023.
So a substantial chunk of information to work with?
Absolutely. And there's this interesting finding from the 2024 event that we should talk about.
Oh, yeah, let's hear it.
They were looking at how systems performed at 2 points in time, 6 months after training and 8 months after training. What they found is that when they ranked the systems based on overall performance, which is measured by this thing called nDCG, the ranking was pretty much the same at both time points. But when they ranked them based on how much their performance had changed.
So not just the score, but how much the score had changed.
Exactly. That ranking was very different. They used this metric called the relative nDCG drop, or RND, to measure that change.
So a system might look like a top performer at both 6 months and 8 months, but it could have gotten significantly worse between those 2 points.
Yeah, precisely. And conversely, a system that might not have been a top scorer initially could actually have stayed much more consistent over time.
So consistency is key here.
Yeah, it's like the systems that were most robust, meaning their performance didn't drop off a cliff, they remained reliable. They weren't always the ones with the highest scores at any given moment.
So it's not about just being good in a single snapshot?
Exactly. It's about maintaining performance.
It's almost like a long-term investment strategy.
Exactly.
Okay, let's move on to the new task for LongEval 2025. LongEval Sci Retrieval. This one's all about finding scientific papers, and it uses data from the core collection.
Core. Yeah, great stuff.
For those listening who might not be familiar, could you give us a little rundown on what core is?
Sure. Core stands for Connecting Repositories. And it's basically a huge collection of open access scientific documents, the full text of the papers.
Open access is important.
It is. It means anyone can get to them. And it's actually the largest collection of its kind worldwide. To give you an idea of how much it's used, they have over 30 million unique users every month.
Wow, 30 million.
And they do over 1 million searches each month.
So clearly, finding stuff in that huge collection is crucial.
Absolutely, and that's what this task is all about.
And how do they figure out what's relevant in this scientific search setting? It can't be as simple as just seeing if someone clicked on a website, like in a typical web search.
Right. That's a good point. For LongEval Sci Retrieval, they're using data about what people click on in the search results to try and understand what they found relevant.
Click patterns, basically.
Exactly. So let's say you're looking for a specific research paper. You get a list of results, and you might click the PDF link to read the whole paper. Or maybe you've clicked the title or even the author's name. All these different clicks give them clues about what the user found most relevant.
It's like a trail of what caught someone's attention.
Exactly.
And the source material actually gives us some cool examples of this search and click data. They're anonymized, of course, but still interesting to look at.
Yeah, you can see the search ID, the actual query the user typed in, and then the top 10 results that were shown to them.
So we can see what options they had.
Right, and then in the click information, you see the same search ID, the specific URL that was clicked, and where it was in the list.
So we know not just if they clicked, but what they clicked and where it was.
Exactly, and that level of detail really helps them figure out what's considered relevant in scientific research.
Now, this is the first time they're running this scientific retrieval task, so the number of time periods or lags they're looking at is a bit smaller to start.
Yeah, they're starting with 2 sets of training data and 1 or 2 sets of test data. But even this initial setup will give them some valuable insights into how this type of search evolves over time.
Now, earlier we mentioned these terms, nDCG scores and relative nDCG drop. Can we break those down a bit? I think it's important for people to understand what they are and why they matter for judging how well these systems are working.
Totally. Those are the 2 main ways they're evaluating the systems submitted to LongEval. First, nDCG, which stands for Normalized Discounted Cumulative Gain. It's a mouthful, I know.
Yeah, it's a bit of a tongue twister.
But it's a very common metric for evaluating these systems. It essentially measures how good the system is at putting the most relevant stuff at the top of the search results.
Makes sense. The good stuff should be right up front.
Exactly. And the discounted part means that if something relevant is way down the list, it doesn't contribute as much to the score.
Because no one's going to scroll forever to find it.
Right, exactly.
So nDCG tells us how good the ranking is at a specific point in time. What about the relative nDCG drop, or RND?
Okay, so the RND, that's where the idea of time really comes in. It measures the difference in nDCG scores for the same system, but across those different time periods.
Okay, so you're comparing how it does over time.
Exactly. So if a system has a high nDCG score on data from, say, 3 months after training, but a much lower score on data from 6 months after training, then it would have a high RND.
Meaning it's not so good at adapting to the changes.
Yeah, basically it's not as robust.
So ideally, we want systems with high nDCG scores and low RNDs, right?
Exactly. We want systems that are good at finding relevant stuff and they stay good over time, even as things change.
So kind of like a well-rounded athlete, good at sprinting and long-distance running.
I like that. A system that can go the distance.
All right, so what's the timeline for LongEval 2025? When can we expect to see some results?
The schedule's pretty clear. The training data for both the web search and the scientific retrieval tasks is set to be released in February 2025. The test data follows shortly after in late March.
Okay, so February and March for data.
Yeah, then those participating have until May 2025 to submit their results.
So May for submissions.
And then the findings should be out in June 2025.
June for findings. All right, that's something to look forward to. And it's not just about this competition, right? There's a workshop, too.
Oh, yeah, absolutely. They have a LongEval workshop as part of the CLEF 2025 conference. This is where researchers, even those who didn't participate in the main tasks, can share their work on this whole temporal effectiveness thing. It's a great chance for the broader community to get together and discuss this important area.
Collaboration is key, as always. And it's great to see all the support from various projects and institutions. We have the ANR Codicare Project, the Austrian Science Fund, and the Linda Claria CZ Research Infrastructure, all backing this work.
It shows how seriously people are taking this challenge.
Yeah, which is really encouraging to see.
For sure.
So to wrap this all up for our listeners, keeping information retrieval working well, it's not a one-and-done situation.
Definitely not.
It's an ongoing challenge because, well, information is constantly changing, and so are we. And that's what makes this work by LongEval so important.
I agree.
It's forcing us to think not just about how well a search engine works today, but how well it's going to work in the future.
And how adaptable they'll be.
Exactly. And the fact that they've added this scientific retrieval task this year, it's really cool.
Yeah, it's a great addition.
Because now we can compare how these systems perform across different types of information and for different types of users.
Like researchers, students, anyone who needs access to scientific literature.
Right, exactly. So it really makes you think, doesn't it?
Yeah.
Like, how confident can we be that the search results we're getting today, are they going to be the same tomorrow or next week or next month?
And will they be as relevant then as they are now? That's the real question.
Right. And that raises so many questions about how we search and how we even evaluate the information we find.
Absolutely. It gets to the heart of how much we can trust those systems over time.
And that's something for all of us to ponder. So thank you so much for joining us for this deep dive into the world of longitudinal information retrieval evaluation.
Yeah, thanks for having me.
It's been a fascinating discussion, and it's clear that this is a really critical area of research, especially as the world around us continues to evolve.
Couldn't agree more.
So until next time, keep searching, keep exploring, and keep questioning.